Good afternoon. Today we're here to talk about testing, procedures, and methods, as well as the future holds for us in our laboratories and what the equipment will look like. Before we get into the meat of this presentation, I would like to offer a little background on myself. I started in the aggregate industry following an injury and unexpected medical retirement from the United States Army in 1998. During my time as a soldier, the importance of critically detailed execution was made very clear, as it could simply mean the difference from coming home or not. In any military move, attention to detail, precision, and execution is paramount and brutally vital. Any failure to perform or communicate is usually left with catastrophic consequences. Actions were led with no gray area. You were either locked and loaded, or you were a risk. We've all come across the person that says they've done it all, and while I do not claim in any way, as my wife will gladly verify, to be all-knowing or perfect in any way. However, I can confirm that I've pushed enough wheelbarrows, raked tons of asphalt, sat atop a roller and a paver for enough miles to call myself dangerous. I've also paid my dues in sales, estimating, and production, both in the mine and at the plant. During my tenure, I took a liking to the structure involved in quality control. While I was production manager for a Colas company, I made the commitment to move from operations to focus solely on the quality control side of the house. Over the years, I have done work for the Army Corps of Engineers in Alaska. I was hired as a quality control consultant in Jamaica to oversee a major development project in Montego Bay. I also had the opportunity to work with the FAA as a quality control director on a runway restoration project. As my career in the aggregate industry progressed, I could not help but notice that while the mantra of quality control seems to demand diligence, as I learned as a soldier, it's painfully clear to see that the standards and execution of those very same procedures had more of a perceptive bearing, adding seemingly growing area to the procedures being used. So let's talk about what we're here today. We're here to talk about increasing the accuracy of the data generated, to reduce the time to test, to define repeatability in the process, and to remove the human error factor as much as possible. Advanced Concepts in Engineering has risen the challenge to silence the industry-wide cry, introducing our totally integrated, totally automated protocol as delivered through the ACE Auto Grade. I'd like to open this discussion with some statistical data, if I could. Global data shows that through 2017, our industry will perform to the tune of some 53 gigatons. That exceeds the historical growth rate of about 4.6%, graduating to some 5.8%. The aggregate industry at large is on track to break 66 gigatons by 2020. In the United States, the aggregate industry generates an estimated $80 to $90 billion contribution to the gross domestic product. As the industry grows, it's likely that the quality standards will follow. The United States sees some 15 million suites of quality control tests per year, a staggering 283.5 million tests on a global basis, at an all-in cost exceeding some $44 billion US. An interesting point to discuss is the failure rate. Most companies have a failure rate, but most they will likely not disclose the same. That failure rate hovers between 4 and 9%, but for the purposes of this presentation, we'll bring that number down to 2%. So what are we producing? Excuse me. One cannot go into an effective business missing the target of the customer. My father used to say to his clients, who are you, where are you going, and how are you going to get there? We're producers and users of aggregate products who want to sell the same. How are we going to get there? We can only get there by navigating the tightrope, meeting the precise standards regulated by the industry. Our labs continue to be held back by antiquated practices, equipment, and methodologies. If for a moment I could, I'd ask you to focus on the top point. This is a quote from Dr. Randy West that most of us know. It is recognized by the industry at large that most of the tests used in quality control and acceptance testing suffer from poor precision. Part of the poor precision is attributable to sampling and testing variability, which are related to the skill and the ability of the technician. The simple fact of the matter is the testing procedure varies from tech to tech. We can teach the process and guide the process. However, when a technician is in his lab, they will vary. If we can look at the next quote, another point from Dr. Rest. Quality control methods are manpower and time intensive, which leads to the inefficient gathering of information needed to monitor and control the production of quality asphalt mixtures. The fact, too, think about, is each suite of tests can consume some 3 hours. A simple gradation can take upwards of 60 minutes. There have been numerous studies and research expeditions conducted looking for new and innovative testing methods and equipment. Unfortunately, most of the advances we see in the industry continue to leave the technology gap between testing side of the house and the production side of the house. When we were conducting an early test with Lane Construction Corporation, we asked the technicians to name the top 3 issues straining the quality control practice. They endorsed the industry cry echoed around the world, focusing in on 3 key elements: human error, time to test, and repeatability. 2 out of 3 of those points are strictly at the hands of the technician. So what's the solution? We can't remove the technician completely. It's time that the industry take a firm posture to empower the technician with the tools they need to do their job in a timely manner with accuracy and repeatability. Here we'll look at the dictionary definition of the word integration. While you read that, let me ask you this. Why is it that while in the delicate determination product mixture analysis, we have been and continue to use an array of antiquated devices? Beyond that question, let me ask you this. With today's technology, why is it that this very same array of devices do not communicate with each other? The future of all industrial processes demands total systemic integration. Years ago, I used to use the slogan of merging yesterday's theories with today's technology. It's due time that that become an industry-wide mandate. Beyond the study of integration, another mandatory key to success across all industries is automation. Looking past the factors of deviation deference, the ultimate success factor of automation is clearly defined through the fact that automation operates under one of the most successful attributes any business can benefit from: the ability to establish a 100% repeatable cycle of events, simultaneously reducing human error. Excuse me. So let's break it down. The simple fact is that in order to update the processes used in quality control to a level that exceeds the advancements awarded on the laydown side of the house, systemic integration and automation are no longer optional. Entering the market to answer the call comes the ACE AutoGrade laboratory. The ACE AutoGrade is an automated gradation testing system: asphalt, concrete, cement, ready mix, aggregate, controlled by a touchscreen interface with voice response, innovative vacuum drying system, accuracy beyond what you're familiar with, 100% repeatable results, and the data is prepared and distributed for you. Machine, welcome Joel, are you ready to test? Through the use of the developments that we've made in this company, we bring the Total Integration, Total Automation protocol. This is a protocol whereby the combination of a series of events conducted by a collection of activities are integrated by means of data-generating processes executed automatically by software-controlled embedded devices without user interpretation, thereby ensuring the accuracy of the process, the results, the data, and the distribution of the same. Machine, the system will now calibrate. Machine, the system check is positive and operational. Machine, the system will now check tare weights. Machine, automation statement. Machine, abort statement. Machine, zeolite heater active. As can be easily seen, there are numerous elements combined in proprietary combination. Through superior engineering, proprietary software orchestrating automation in all of the items you see before you, the ACE Auto Grade firmly delivers a first-to-market product guided by our trademarked Total Integration, Total Automation protocol. It's worthy of mention that the system demands a standard 120-volt, 15-amp service, so you, the user, are no longer required to provide dedicated services. The unit is available in a 50-cycle system as well. I'll be happy to go over some of these items individually following the presentation during the question and answer session. The design features of the ACE Auto Grade introduce a whole new level of flexibility and mobility to aggregate testing, requiring nothing more than a generator and a bucket of water to operate. Beyond the technological excellence detailed in the previous slide, I'm certain that you will find the range of capacity available in the different models to be eye-opening.
3 LSB 225-pound sensors with a 50-pound weight on top. What I'm going to show is when I put a 0.1 gram sensor or 0.1 gram weight on it, this will take the reading of that extra weight. So currently it's reading 0 grams because I just carried it. You just put this tiny little thing onto this, and then voila, 0.1 grams.
This video clearly shows the advantages of ACE's triangulating scale system. The ACE Auto Grade is unique. It is the only current offering for complete end-to-end gradation testing. The ACE Auto Grade is the only unit producing a certifiable gradation result, automatically computed and uneditable. When we were putting this system together, one of the things that we were looking to do was to protect the integrity of the results. Our programmer is one of the best in the country. Some of you may be familiar with the SOARS Deep Space Telescope in Chile. As a matter of qualification, the gentleman that writes our software and controls our automation is the same person, Mr. Bruce Bushy, who wrote the operating software that controls the SOARS telescope. The ACE Auto Grade has numerous proprietary features to optimize the potential for accuracy and repeatability during the testing process while increasing the user's efficiency add-back, resulting in either increased tests or reduced operating expenses. We'll talk about that a little bit further in the presentation. When we designed this unit, again, wanting to automate every part of it, you'll notice in the lower right-hand part of the screen, that's a view of the inside of the testing chamber without the cage. The unit is self-cleaning and coated with an ultra-hydrophobic. With the ultra-hydrophobic, those of you that are familiar with it, if there's any material left behind, the ultra-hydrophobic will grab it, will force the water to grab it and take it with it. So what makes the machine different than what you're familiar with? Through industry-leading thinkers, Advanced Concepts and Engineering has taken a conglomeration of industry-wide demands and merged them all into the unit you see before you. All of the mandated steps in the process have been automated. All of the mandated steps in the process have been integrated. However, not only have we protected the integrity of the value of the information, but they've been integrated in a fashion to give you additional security in your results and the time it takes, but also in a way that offers the sample some protection. Without going into a full physics lecture on vacuum properties, the effects of heat versus cold, I will simply state a fact that we all know. Heat destroys and cold preserves. When you remove a sample to the oven, as soon as it begins to heat, it's already begun to feel the varying effects of sample degradation, whether you knew it or not. Naturalist Ethan Shaw of Oregon reports that even at minor temperature variations, boulders and rocks will break. Thermal stress on different types of aggregate, while in conductive heat settings such as hot plates, invites thermal shock, thereby instituting rapid thermal fatigue in the specimen being studied. There's a plethora of advantages to vacuum drying, simply summarized by the summary report by Mr. Pockrell. The specimen remains at room temperature, which helps to retain the characteristics that can be altered due to heat. A lot of you have there's a piece of equipment in your laboratory, or most laboratories, that dries by vacuum. This is something that's been a standing acceptance for some time now through both ASTM and AASHTO. Further supporting the vacuum process is ASTM's 7227, where it clearly indicates, quote, "This practice can be used for drying other construction materials such as concrete, soils, aggregates, and loose asphalt mixtures." This method has already been accepted some time ago. However, the industry remains cautious on this method, although it clearly protects the sample. A caution effort that is beyond reason. If I can protect the integrity of the sample, and I can remove the fact of sample degradation by heat, why is that not a standard demand through the process? Before we get into the performance characteristics of the ACE auto grade, I have a question. In a standard gradation on a 19mm minus, using a relatively common arrangement of sieves, have you ever stopped and thought just how many times do you handle the sample? You're going from the scale to the pan, to the hot plate, to the scale, to the sieves, to the scale, so on. Stop and think about that for a second. This picture in front of you is a gross image of just what we're doing. Scale to heat 1, to scale 2, to sieve stack 3. 14 times you're handling one sample. Regardless of your industry classification, I think we know that the more you handle a product, the less efficient our operation, the greater risk of product integrity. The more you handle a sample, the less effective you are, and your efficiency rate plummets. I think we can all agree that handling the same sample 12 to 16 times is anything but effective and efficient. In the design of the ACE auto grade, optimizing effectiveness and efficiency. You load the sample once. You're handling a live sample one time. When you unload the sample, it's already been tested and can be discarded depending upon what you want to do with it. But your results are done before you touch it a second time. There's not a piece of equipment out there now that gives you the ability to say, I can do a complete gradation and handle the sample once. Now the ACE AutoGrade answers that call. When we look at the time it takes to do a test, there's a substantial risk factor. Where we said previously that a suite of tests can take approximately 3 hours. If you have a 300 ton an hour plant, you're leaving some 900 tons of material in jeopardy. But even worse than that, let's go back to what we talked about at the beginning of the presentation. 66 gigatons. So our partners that produce the equipment on the production side of a house, they've already adjusted their equipment to meet those demands. Our friends at Aztec produce a plant that's capable of 600 plus ton an hour. 600 tons an hour times 3 hours is 1,800 tons of material going down the belt. Now, if you're going to risk 1,800 tons of material, are you effective? No. Are you efficient? Absolutely not. What are you? You're a liability. Now that we've discussed a good amount about how the unit does what it does, let's look at some of the comparison results. The comparison on the screen in front of you, you can clearly see a difference in the time requirement. This is a standard gradation, again, 19 millimeter minus material. To the left is conventional, to the right is the ACE AutoGrade. If you go down to the bottom, total time for sample test on either side, you can see that in our laboratory, we came up with an average time of 48 minutes. If you go to the right, using the same material, we came up with an average test time of 25 minutes. One of the things that's different about the ACE AutoGrade that I think a lot of you will enjoy is that there's no more pencils, there's no more pens, there's no more crayons and calculators. I learned what I learned from a gentleman who is up above us all, looking down on us now. A gentleman by the name of Bob Reed was my mentor, if you will. He actually signed on my very first NETTCP certification and registration. We would go into the lab, and the interesting thing about Bob is there was always a plethora of pencils and erasers. That's no more. Those times have come and gone. I only wish Bob Reed was here to see what he essentially helped us to create. Let's talk for a second about post-burn. Right now, the machine is run a post-burn gradation while we're talking. One of the things that we've done is allowed and made efforts so that all of this time you spend cooling the sample, you're risking the challenge. Should you want to, and I'm not advocating that you do or that you should, but should you want to go directly from the ignition oven to a sieve, you could do that with the ACE AutoGrade. 11 minutes later, the report's in your hand. This is a series of tests that we've run. This is a 12.5 millimeter blend, 5 standard method tests, one equipment we've been using for years, and 5 run through the ACE Auto Grade. Indeed, these samples are small at only 1,000 grams, but they do more than prove a few key points. I want to draw your attention to the columns on the far right. It's your standard average and your ACE Auto Grade average. You'll notice there's a substantial difference in your percent moisture overall. You have 3.91% on the standard size, 4.14% on the ACE Auto Grade. That's a notable difference, especially when you're talking about a 1,000 gram sample. So we'll go through the numbers. Now, before I continue to go through some of these numbers, let me point out the fact these are grams retained. This is not percent passing. When you look at your numbers on your 12.5 millimeter down to your number 50, the standard process, there's more material there. You're going 8.5 to 8.5, 38.9 to 38.7, 84.3 to 84.0, 93.3, 92.9, 112.4 to 111.9, 190 to 189.4, 229.6 to 229.2. So you have more material on your sieves in the standard method for above the 50 and higher. But when you get down to the number 100, you'll notice that that process seems to shift. You go 100.1 to 100.5, 58.1 to 58.6, 44.7 to 44.8. What's interesting to note here is that what's happening is you'll notice that you're getting a little bit more of your fines, your super fines, but your percent moisture has a serious difference. Let's move on to some of the other things that we can do with the ACE Auto Grade. When you do a gradation, you do your math, you do your calculations, and then you'll put it into a computer or whatnot. You'll say, well, I got to compare it to this mix design, whatever it is you're working on. When you go into it, you choose, and when you get your results, it'll come out plotted against your control points. Some of you use the restricted zone, some of you don't. If you do, you can plot it against that. When you're doing a mix design, you generally start with an educated guess. Wouldn't it be nice if you could just simply slide your fingers up and down and draw the mix design? Certain models of the ACE Auto Grade, you can draw your mix design. The unit takes your design that you've drawn, crosses it against historical test data in the unit, and will produce a successful mix for you. Should you prefer, those of you that are enjoying the totally automation, we have an optional job mix formula module. In this module, you'll select your control points. Then you'll select a range of tests on material. The unit will blend every possible combination, up to 1,000 possible combinations per second. This is especially advantageous if one wanted to conduct some financial analysis on the cost of different job mix. Each unit comes standard with a 4-blend JMF, 4-aggregate blend JMF. At present, we're completing an 11-aggregate blend unit for an Oldcastle company client.
See me. Don't stare at me. See me. See me. See me to know this one.
Now that we've had some discussion about how the Ace Autograde does what it does and why it does what it does, at some point in time in the last half hour, you likely thought about maintenance, as you should have. In looking to maintain the posture of integrated and automated operation, the user should not be concerned about maintenance, as the Ace Autograde has been designed to allow you to concentrate on the task at hand. Of course, it comes with a standard industry warranty. We wanted to ensure the experience with the Ace Autograde remains more than you expect by offering the optional product maintenance plan where we come to you. 4 times a year, you'll be visited at your location by a certified Ace technician. They will be changing lubricants, oils, conducting performance analysis, tuning as required, replacement of couplers and lovejoys or spiders that may be required, calibration of your scales, your pressure, moisture, and temperature sensors, as well as the total overall mechanical systems analysis. The only user requirement, depending upon usage of material, would be the replacement of the water filters. Drawing your attention to the lower right-hand part of your screen, you can see that the water returning from the chamber cycles through a filter and back into the tank. These are filters that are easily available at your local Home Depot, Lowe's, or hardware store or whatnot. So what's next? What do you do with the data? Key it into an Excel spreadsheet. Key it into some database service. The second you start keying in anything, again, you are inefficient. Your effectiveness is dropped dramatically. You're bringing back the human error factor. If I owed you $2,000 and I put the decimal place in the wrong spot, one of us isn't going to be happy. Data management is nice, but when there is no active integration between the source of the data and the storage of the data, you again are ineffective. If I'm a pitcher and I throw a baseball across an empty plate, 107 miles an hour lower left corner, can I prove it? Can I verify it? And is there record of it? The Ace Autograde was designed to be able to move the data in several directions at the same time. It's on the screen for the user. You can automatically send your reports to the road, to the plant, to your supervisor, to the regional manager who's 3 states away, or to the company owner that may be overseas. While it does that, certain models will send that same information to a cloud-based database that not only manages and tracks your data, but will also interface with trends, costs, and has inventory and project management tools built right into it. Not that I want to take a shot at a system that most of you are likely using now, but why would you take the time to key in your data while paying a king's ransom for that, when for the cost of a steak dinner once a month, the Ace Autograde will do that for you automatically every single time a test is run? Earlier we talked a little bit about cost. Having 20 years in the industry, I can attest to spending these dollars. Assuming a 270,000 ton annual production with an all-in cost of $35 an hour for a technician, based on a relatively common testing interval, you're going to spend about $194,000 a year strictly on the T11, T27. Gradation and wash. Doing the same amount of tests with the same all-in cost on your technician, you're $149,000, therefore saving you some $45,000. Earlier we talked about that efficiency add-back. That efficiency add-back can go in a number of ways. You can say, well, my ROI on the machines, 17 to 19 months. My efficiency add back 45,000. Maybe I'm going to turn that into more tests. Maybe I'm going to hire somebody else. The other thing beyond the efficiency add back, you remember earlier we talked about a 2% rejection rate. In this example of a 270,000 ton production facility, that 2% rate that's protected now with the ACE Auto grade ensures some $540,000 in liability exposure from faulty test results. We'll now go into about a 15-minute question and answer session.